SMO 2019 Junior Section First Round Singapore Mathematical Olympiad. And I released many other years, many other countries, many other sections. If you had any question about any other problems, and if you want the next videos, subscribe my YouTube channel, turn on the bell to have next videos. Okay, and if you had any question about my solutions, feel free, as I said before, to send message to my WhatsApp number in the description and comments. Okay, first problem. Which of the 5 numbers, these numbers, and because the quality is low from second page, it will be better. Here the quality is a little low. It has one resource I've downloaded, but I read from the problems to understand it completely. Which of the 5 numbers, these numbers, let me write. 2 to the power of 30, 3 to the power of 90, 4 to the power of 14, 6 to the power of 12, 9 to the power of 10, which of them has the largest value? So for solving these types of problems, you should reach equal power. If you want to do for all of them, it's not possible, but you can check, for example, similar things. Here, it will be 3 to the power of 20, so you can get rid of this. It is what? 2 to the power of 28, so it is 2 to the power of 30. We want to find largest, so you can get rid of this. And if you check these two numbers, so get rid of this means this, it will be 312, 212. Here it's 320. If you want to check which of them is greater, you can divide by 312. It is 38. Now we reach same power. So it will be 2 cubed, 8 to the power of 4. It is 3 squared, 9 to the power of 4. It is greater, greater, greater. So it is greater. You can cancel this. Now let's check 230, 320. If we want to check these two numbers, again, we want to reach same power. It will be 8 to the power of 10, 2 cubed to the power of 10. It will be 3 squared to the power of 10. It is greater, so you can cancel this. So the answer is 3 to the power of 20, which is 9 to the power of 10. So the answer is E. SMO 2019 Junior Section First Round Problem number 2. In a strange island, there are only 2 types of inhabitants: truth tellers who only tell the truth and liars who only tell lies. One day you meet 2 such inhabitants, A and B. A said, exactly one of us is a truth teller. B kept silent. Which of the following must be true? Okay, for solving this problem, A only says this expression. So you say, okay, if A is truth teller, because he should tell truth, he said exactly one of us is a truth teller, so B is a liar. If A is liar, so he should lie, exactly one of us is a truth teller, so B should be what? If B is truth teller, so we can conclude what? We can conclude A said truth, but A is a liar, so B should be liar. So we conclude B always, in these 2 cases, in all cases, is liar. Be a liar, but A can be truth teller or liar. So A says both A and B are truth teller. Wrong, because A can be also liar. B, both A and B are liars. No, because A can be both of them. A is truth teller. Only A is liar. Not enough information to decide. So the answer is E. SMO 2019 Junior Section First Round Problem number 3. If x minus 1 over x equals 3, what's the value of this term? Okay, if we consider the first one, x minus 1 over x equals 3, multiply both sides by x, it will be x squared minus 1 equals 3x, so x squared equals 3x plus 1. So you can replace x squared with 3x plus 1. Here the degree is 2. You need to only replace once. In some problems, the degree is 2000, like some problems of USA, you need to use that several times, or you need to divide 2 polynomials. If you want to learn these types of things, solve USA, AMC, AME, or other Olympiads, want to learn the ideas, as I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, so let's consider this one. It is 21 over 2 minus 3 over 6 x squared. X squared is 3 over 6. You can write 1 over 2. X squared is what? 3x plus 1 plus 3 over 2x. So you can cancel. It's negative 3x over 2. It is positive 3x over 2. You can cancel. This 21 over 2 minus 1 over 2 will be 20 over 2 will be 10. So the answer is E. SMO 2019 junior section first round problem number 4. Let x, y, and z be positive integers satisfying these two equalities. If x and x1 and x2 are two distinct solutions for x, what's the value of x1 plus x2? Okay, here the first equality, I write it, x squared plus y squared plus z squared equals 2xy plus 1. The second equality is x plus y plus z equals 22. So here I can say it's x. If I take 2xy to left hand side, I can write x minus y squared plus z squared equals 2 times 1 is 2. So the only possible case is that x absolute value of x minus 1 is 1 and absolute value of z is 1 because the problem says x, y, z are positive integers. So you conclude z is 1. So we consider two cases, x minus y equals 1 or x minus 1 equals negative 1. So the first case, x minus 1 equals 1 and z equals 1. From this second equality, we know x plus y plus z equals 22, z is 1. We can replace, we want to find x, so you can say, okay, y is what? Y is x minus 1. So if I replace y with x minus 1, so x minus 1 plus 1 will be x, so 2x will be 10, 12, 20, 22. So if you divide by 2, x will be 10, 11. Case 2. X minus y is negative 1. Z is 1. So we can conclude y is what? Take it here. Y is x plus 1. Now you use again second equality. You say x plus y plus z equals 20, 22. It is 1. Y is what? X plus 1. So you can say, okay, 2x plus 1 because of this 1 plus 1 plus 2 is 20, 22. So 2x is 20, 20. So x is 10, 10. So one root is this, one root is this. The problem says x1 plus x2 is what? So it is 10, 11 plus 10, 10. If we add up these two numbers, it will be 20, 21. So the answer is C. SMO 2019 junior section first round, problem number 5. In a quadrilateral ABCD, let me maximize this. The diagonals AC and BD intersect at O. The point O, suppose that BAD, let me call this angle, for example, alpha, plus ACB, this angle beta, equals 180. So alpha plus beta equals 180. BC is 3, AD is 4, AC is 5, this side is 5, this diagonal, AB is 6. What is the value of OD over OB? OD over OB. Again, I think only in this exam we will use ratio lemma 2 times. So it is so much important in SMO problems, ratio lemma. If you use two sine rule in these two triangles, then by ratio lemma, you can say what? There are around 50 important ideas in geometry that are useful from qualifying level up to IMO. If you wanted to know them, feel free to send message to my WhatsApp number in the description and comments. Also, subscribe my YouTube channel to have next videos. Okay, so sine alpha over sine alpha 1 over sine alpha 2 equals OD over OB times 6 over 4. So if we find sine alpha, so let me tell OD over OB. If we divide both numerator and denominator by 2, it will be 3 over 2. So OD, we want to find what? OD over OB. So OD over OB equals 2 over 3 times sine alpha 1 over OB, OD sine alpha 2. Yes, sine alpha 1, sine alpha 2 here. Reciprocal of that times this. So we should find sine alpha 1 over sine alpha 2. In this triangle ACB, we have all the sides. So we can find cos beta, cos alpha 2. So we can find sine alpha 2, so this one will be okay. Alpha 1 is what? Alpha minus alpha 2. So we can find sine beta cos beta, so we can find sine alpha minus alpha 2. So let's at first find sine and cos alpha 2. So sine alpha cos alpha 2 is what? By cos rule here, you can say it's 25 plus 36 minus 9 all over 2 times 5 times 6. 36 minus 9 is 27. 27 plus 25 will be 52 over 2 times 5 times 6. If we divide both numerator and denominator by 4, it will be 3 times 5, 15. So it will be 3 over 15 cos alpha 2. Sine alpha 2 will be what? Because we know cos is sine of any angle between 0 and 180 is positive. So you can say it is alpha 2 is angle of this triangle. So sine alpha 2 is 1 minus this squared, square root of that. So it will be 225 minus 13 squared, which will be 169 over 225. You should consider square root, it will be 15. If we consider it is what? 15 minus 9 is 6. 11 minus 6 is 5. So it will be root 56 over 15. Now, the next one. We want to find sine alpha, cos alpha. We should use beta because beta plus alpha is 180. So again, if we use cos rule, cos beta is what? Cos beta will be, let me take it down a little. So sine cos beta is what? Is 5 squared 25 plus 3 squared 9 minus 6 squared minus 36 over 2 times 5 times 3. Now it will be what? 25 plus 9, 34 minus 36 negative 2 over 2 times 5 times 3. If we divide both numerator and denominator by 1, it will be negative 1 over 15. Now, if you want to use sine beta, we know beta is angle, so sine of that is positive. 1 minus this squared, 225 minus 1 will be 224 over 15. And if we take 4 outside, it will be 2. 4 times, it will be 56 over 15. Now we found cos beta, sine beta. So we want to find sine alpha 1. Sine alpha 1 is what? Is sine alpha minus alpha 1, alpha 2. It is sine alpha cos alpha 2, you should memorize this formula, minus cos alpha sine alpha 2. Now, if you want to check with beta, we know because alpha plus beta is 180, it will be sine beta cos alpha 2, and because alpha plus beta is 180, so cos alpha is negative cos beta. It will be plus cos beta sine alpha 2. Now we replace. Sine beta will be 2 root 56 over 15. Cos alpha 2 is what? 13 over 15. Plus cos beta sine alpha 2. Cos beta will be negative, let me change it to negative 1 over 15 times sine alpha 2 will be root 56 over 15. Now, if you factor from root 56 over 15 squared, it will be what? 2 times 13, 26 minus 1, 25. If we simplify, it will be root 56. It is 3 squared, 5 squared. We cancel 5 squared. It will be 3 squared, will be 9. So we found sine alpha 1 is this, sine alpha 2 is this. So the answer is what? 2 over 3 times sine alpha 1 over sine alpha 2. It will be root 56 over 9, sine alpha 1. Sine alpha 2 is root 56 over 15. If we cancel these two terms, it will be 2 over 3 times 15 over 9. So here we simplify 3 here, 5. It will be 10 over 9. So the answer is 10 over 9. Let's see the problem. The answer is D. If you had any question with the solution of this problem or also other problems, as I said, feel free to send a message to my WhatsApp number in the description and comments. SMO 2019 Junior Section First Round, short questions, problem number 6. In the following diagram, all lines are straight. What is the value in degree of a plus b to j? Okay, so we want to find a plus b. So a plus b, if we consider this, it is what? It is 180 minus a minus b. It is what? 180 minus c minus d. 180 minus e minus f. 180 minus h minus g. 180 minus I minus j. So let me call this one, for example, t. So, or we can write with small t. So if I calculate all of them, if I add up all of them, it will be what? It will be 1, 1, 2, 3, 4, 5. It is 5-sided pentagon. So the angle is 180 times n minus 2. Sum of the angles is 5 minus 2. This is basic formula. There are around 50 important formulas that are useful in geometry from qualifying level up to IMO. If you want to know them, as I said before, feel free. Send message to my WhatsApp number in the description and comments. Okay, so is this, and if you add up all these numbers, 181, 2, 3, 4, 5, it will be 5 times 180 minus a minus b minus, it will be minus t. Now we have one equation, one variable, we can find t. It will be 3. So you say, okay, t equals 5 times 180 minus 3 times that. We factor from 180, it will be 5 minus 3, it will be 2. 2 times 180 is 360. So the answer, t equals 360 degree. SMO 2019 junior section first round problem number 7. Let x be a positive integer. Suppose that the highest common factor of x and ad is 40 and the highest common factor of x and 252 is 12. What's the minimum value of x? Okay, for this problem, let's write HCF, highest common factor of x, or GCD. X and AD is 40 and highest common factor of x and 252 is 12. So we should at first prime factorize this number. It will be HCF of x. 18 is 5 times 16. 2 to the power of 4 times 5 is 40. 40 is 2 cubed times 5. And next one, highest common factor of x. 252. It is 2 times 1, 2, 6. You can say 2 times 2 times 63. So you can say 2 squared times, it is 9 times 7. 3 squared times 7 equals 12. 12 is 2 squared times 3. The problem says, what's the minimum value of x? So here we see that for x, consider only 2 alpha, 5 beta, and 3 to the power of, let me write 3 beta, and 5 to the power of theta. Okay, so we don't need 7 because here the GCD or HCF doesn't have 7. So here, from first one, 2 to the power of 4, we have 2 to the power of 3. So we conclude alpha is exactly 3 because it should select minimum for power of 2. It is 3, so minimum is 3. It is 4, so it is exactly 3. It is 5, 1. So here you can conclude theta is at least 1 from first one. And 3 beta is not, we don't have any condition for this. For second one, it is 2, it is 2, so it's okay. 3, it is 2, it is 1. So minimum is 1. So we conclude beta is 1 and theta is at least 1. So here, because it's at minimum, so minimum x equals 2 cubed times 3 to the power of 1 times, because theta is at least 1, because of here 5 to the power of 1. It will be 8 times 3 times 5. 8 times 5, 40. 40 times 3, 120. And the x is positive integer, so the minimum x equals 120, and the answer is this. SMO 2019 junior section first round problem number 8. Suppose that m and n are positive integers where 100 m over n is a perfect cube greater than 1. What's the minimum value of m plus n? Okay, so it is 100 times m. So 100 is what? M over n. 100 is 2 squared times 5 squared. So here, because we want to find minimum value of m and n, we can consider that, okay, m, let me correct it. Okay, we can consider that m and n only have 2 and 5. So let's see. We want to, at first, let's try, because we want to find minimum, let's try to find some example. If we want to reach cube, you can divide also. You can get rid of one of them. For example, 4, get rid of them, then multiply by 5. Or we can multiply by 2 and divide by 5 squared. So in this case, m is this, n is this, m plus n is 9. If we want to reach a smaller one, we need at least 1 5. And let me see if we check, for example, we need at least 1 5. If you want to erase this, you need 25. 25 is greater than 9. If we want to multiply, we need 5. Now we should correct this one. If we want to correct it, in numerator, we should place 2 here, which is 10 is greater than 9, because 10 plus some positive integers. So it is better to have 4 here, 5, 4. So the answer is equal to 9. SMO 2019 Junior Section First Round Problem number 9. What is the largest possible 2-digit positive integer that is 18 more than the product of its 2 digits? Okay, if you want to write, you say, okay, 2-digit positive integer, so AB, it is 18 more than plus the product of its 2-digit AB. So you say, okay, B plus 10A equals 18 plus AB. And if you want to check, you can, for example, consider mod 10, mod something. So if you check, for example, for we want to increase A9. You say, okay, if A is 9, let's see what happens. You say B plus 9D equals 80 plus what? Plus 9B. And then you say, okay, 8B equals what? 90 minus 18, which will be 80, 72. And we see B is 9. So 99 is answer of this problem. And you can check 9 times 9, 81. It is exactly 18 more than this. So 99 is satisfy the condition, and it's the problem says largest possible. So 99 is the greatest 2-digit positive integer. So the answer is equal to 99. SMO 2019 Junior Section First Round Problem number 10. A teacher spent $77 to purchase 25 gifts for her class. There were 3 different types with respective unit prices: $2, $4, and $5. If she bought more than 3 gifts of each type, how many of the $2 gift did she buy? Okay, so suppose from $2 we have X, from $2, from Y we have, from $4 we have Y, the number, from $5 the number is Z. So we can say what? Spend $77, so 2X plus 4Y plus 5Z equals 77, and 25 gifts. So X plus Y plus Z equals 25. And the problem says more than 3 gifts of each type. So X, Y, and Z are greater than 3 because they are integers greater than equal 4. So let's consider this case. Because X plus Y plus Z is 25, you can factor from 2X, 2Y, 2Z. So you can say, okay, 2 times 25, 50. What is left? 2Y plus 3Z. 2Y plus 3Z is 77. So 2y plus 3z equals what? Equals 27. Now, if we consider the cases, y should be multiple of 3. And also, if we consider, so let's consider z at first here. We know it is at least what? At least 4. So if z is 4, then even, it is odd. So z must be odd. So at first, you should check z is 5. It will be 15. 27 minus 15 is what? 12. Y is 4. And let's check y is 6, I think. Let me check it again. 15 plus 12, yes. If z we know it's odd. If z is 7, Then 21, 27 minus 21 will be 6. And 6 over 2 will be what? Will be 3. And the rest of that, because y is at least 4, so the rest of that will be bad. So z is 5. Y is 6, because if you increase z, then y will be decreased, and 3 also is bad. Y is 6, so x is what? If we replace 6 plus 5, 11. 11, 25 minus 11, which will be 14. So the problem says how many of the $2 gift did she buy? The answer is 14. And SMO 2019 Junior Section First Round problem number 11. In the following diagram, ABCD is a rectangle with AB equals 4, BC equals 6, points E and F lie on the side here. E and F lie on the sides BC, and AD respectively, such that BEFD is 2. It is 2, it is 2. Okay, points G and H lie on the side AB and CD respectively, such that AG equals CH equals 1. It is 1, it is 1. So here you can say it is 4, so it is 3. It is also 3, so it is 6. It will be 4. It will be 4. Suppose P lies on EF, such that the quadrilateral BGPE has area of 5. Let me write with this. Area of this is 5. And what's the area of the quadrilateral F? Let me see. FDHP. FDHP. So here the answer wants to find this. Okay, so let's do something. Let's erase these two things we know. So it is 5 we know. Let me write with red. We know it is 5 and we want to know it is what? So if we connect this point, let me draw with white this one, and for example this one. Now let's connect this point and this point. Okay, so the area, let's write area of each one. It is 1 times 4 over 2. It is 2. It is 1 times 4 over 2. It is 2. This one. 5 is all of this quadrilateral. This one is 2 times 3. 6 over 2 is 3. This one also 2 times 3 over 2 is 3. Now we want to see what can we say. Because it is 3, the whole is 5, it is 2. So you can write 2 and you can erase this. 3 plus 2 is 5. Now if we want to consider the other parts, so this area, it is a trapezoid. You can say 3 plus 1. 3 plus 1 is altitude times 2 plus 4 all over 2. It will be 4, it will be 6. 4 times 6, 12. 24 over 2, 12. So here the whole is 12. 2, 3, 5. 5, 2, 7. So 12 minus 7 is 5. So the area here is 5. Now we conclude what? Because this area over this area is 2 over 5. You can say, okay, it is for example 2x and this one is 5x. Now we can find the sum of these two areas. Then because the ratio is 2 over 5, you can find each of them. Well, how we can find this? We know the whole area of this rectangle is 3 plus 1, this length, 2 plus 4, or we can say it's 4 times 6, 24. Then 24 minus this trapezoid will be minus 12. Minus 3 minus 2 will be what? 5. It will be negative 17. 24 minus this is 7. Now because it is 7, you can say, okay, it is 2 over 7 of this. It will be 2, so. And this will be 5 over 7. It will be what? It will be 5. Now the ratios are okay. Now the problem says what's the area of this quadrilateral? 5 plus 3 this area plus this area equals 8. So the answer is 8. SMO 2019 Junior Section First Round Problem number 12. Two boxes A and B contain an equal number of toys if one of the toys with value $5 is transferred from A to B, the average. So let me show you this. So here, suppose we have A, we have B. The value here is VA, the value here is VB. Now one toy with value $5 transferred from A to B. So it will be what? VA minus 5. And it will be what the value here? VB plus 5 for B. The average value of the toys in box A. So suppose that the number contain equal number of toys. So suppose we have T here, T here. Now that you remove transferred one from here to here, from A to B, it will be T minus 1, T plus 1. So let's at first consider this. The average value of the toy in box A will decrease by $1. So VA minus 5 over T minus 1, it decreased by 1. So VA over T minus VA minus 5 over T minus 1 will be 1. Why the average value of the toys in box B will increase by 1. So you can say, okay, VB plus 5 over T plus 1 minus VB over T is 1. Why? Okay, suppose every toy has a positive value. Okay, what's the total value in dollars of the toys in the two boxes? So we want what? We want VA plus VB. What's the total value? It is what? Okay, so let's simplify the first equality. If we multiply by T times T minus 1, then we have VA T minus 1 minus VA minus 5 times T equals T times T minus 1. Then let's see what can we do. We have VAT here, negative, you can cancel them. Then we have what? Negative VA plus 5T equals T times T minus 1, which you can write T squared minus T. So if you take this right hand side, VA equals all these things, 5T will be 60. 60 minus T squared will be T 6 minus T. So VA is this. Now let's simplify this equality. Multiply by T times T plus 1, VB plus 5 times T minus VB times T plus 1 equals T times T plus 1. So here, VBT you can cancel, negative VPT you can cancel. Then we have 5T minus VB equals T squared plus T. So if you take it to right hand side, you can say VB 5T minus T 4T, you can say T4 minus T. Now VA plus VB equals what? T factor from T, 10 minus 2T. And it will be what? You factor from 2, 5 minus T. Now here, the number is positive T, the number of toys. Why? Because we have 5 here, so T is positive. And we can say, okay, the problem says, let's see, every toy has a positive value. So you can say, because here we want to consider T cannot be greater than 4. Because if T is 5, then it will be negative. So T can be only 4, 3, 2, 1. So if T is 5, then VB will be 0. Means we don't have any toy in B because every toy has positive value. So because T, so it means what? It means that you have 4 toys with value 0 and each toy has positive value. It's contradiction. So we should consider T3, T2, T1. So if we consider for T1, T2, T3, let me write T here. Then let's calculate VA, VB. Okay, VA is what? VA is T times 6 minus T. So it is what? T times 6 minus t will be 1 times 6 minus 1, 5. For 2, it will be 2 times 6 minus 2, 4, 2 times 4, 8. For 3, 3 times 6 minus 3, 3, 9. VB is what? VB is, let me check, yes. VB is t times 4 minus t. It's 1, 4 minus 1, 3. It's 2 times 4 minus 2, 2 times 2, 4. 3 times 4 minus 3, 1 is 3. So the problem says we transfer 5 from VA and then we calculate the average. If you transfer 5 in this case, you don't have any other toy here, so over 0 doesn't have any meaning. So this case is impossible. Let's check these two cases. We know that the answer VA plus VB is 2t. VA plus VB is 2t times this, or you can add these two things. Here it's 12, here is 12. So in both cases, the sum of value is 12. So the answer is equal to 12. SMO 2019 Junior Section First Round Problem number 13. In the following diagram, ABCD, ACFE, ABCD, ACFE, it is this, and ECHG, ECHG are all rectangles. If AB equals 6, BC equals 8, what's the area of rectangle ECHG? So let's consider it is 6, it is 8. So AC squared, you can say AC squared is 8 squared plus 6 squared, which is 100. So AC equals what? AC equals 10. Now it's 10. So we found AC. Now, so here we say, okay, suppose we know it is 90 degrees because the problem says it is rectangle. It is 90 degrees, so we can consider if it is alpha, it is 90 minus alpha, it is 90, so it is alpha. And you can say, okay, these two triangles are similar. AED is similar to CDF, triangle CDF. Now, we say, okay, if this length is x, it will be 10 minus x. And it is 6. This hypotenuse is 8. Now, we try to find this length, AE. Okay, if we want to write the ratios, AED, 8 hypotenuse over 6 equals, let me call this one y, it is also y because it's rectangle. Y is over its opposite sine 90 minus alpha. Sine 90 minus alpha here is x. 10 minus x alpha here, so alpha over y. Now we want to find what? We want to find y. If we find y, then we find this rectangle. Because we want to find y, so here you can simplify, it will be 4 over 3. So you can say x is 3y over 4. And then if you replace here, 4 over 3 equals 10 minus x. 10 minus 3y over 4 over y. If we cross multiply, we have 4y equals 30 minus 9y over 4. And then we can say, okay, 4y plus 9y over 4 equals 30. So then, if we multiply both sides by 4, 16y plus 9y, 25y equals 30 times 4. And then we divide by 5. It will be what? It will be 5y, or you can say y equals 6 times 4, 24 over 5. So we found y equals what? Now we do the same thing to find length of CEGH. So if you want to find CE, so y is what? 24 over 5. CE squared, if we use Pythagoras theorem, it is y squared, 24 over 5 squared, plus 10 squared, which is 100. So Here it will be 25 and okay, 24 squared is 576 plus 25 times 100 will be 2,500, which will be 6703. 3076 over 25. Now we can say, okay, if we want to consider CE is what is, it is multiple of, let's check 4. So you can say 2 times, if you divide by 4, it will be 7. 47 times 4, 28, 27. 6 times 4, 24, 36, and 9 over 25 will be 5. Okay, now with the same thing, we want to find length of this rectangle. Rectangle CEGH. So C, we found C is what? We need to find only EG. So you call again this one W. This one is CE minus W, which will be 2 root 769 over 5 minus W. And then we want to find what it is. This length is, for example, let me call this one T. This one is T. If we want to write the ratios, it will be what? Here, if we check, here, we can say, okay, again, it is beta. This is 90 minus beta, so it is again beta. So if we write the ratios, these two triangles EGF is similar to CFH similarly. So here I want to find what? I want to find T, then the problem will be solved. So I say, okay. The hypotenuse EF. EF is what? EF is 10. 10 over now hypotenuse in this part. In this part, it's what? If you pay attention, it will be y. Y was what? 24 over 5. It is equal to what? So 10 over this one. EF 10 over y, which is 24 over y, equals T. It is 90 minus beta, 90 minus beta W, and it is equal to beta 2 root 769 minus W. It's over 5 this part. Is beta over T. Now here our goal is to find T. So you say what? You say, okay, if we divide, it will be, if I divide by 2, it will be 5, it will be 12. So it will be 25 over 12. So we said we want to find what? We want to find T. W is what? 12T over 25. And we can replace it here. 2 times root 769 over 5 minus 12T over 25. All over T. Now, here. If we multiply, it will be 25T equals 24 root 769 over 5 minus 12 times 12T. It will be 144T over 25. Now it will be this. Okay, so let's simplify. We can multiply by 25. It will be 625 plus 144T equals 5 times this 12769. If we add up these two numbers, 4 plus 5 9, 4 plus 2 6, 6 plus 1 7. So T will be what? Will be 120 over root 769. So T is this. Now this length C is what? C is 2 root 769 over 5. CE is 2 root 769 over 5. We want to find the area, so we should multiply these two terms. So T times CE is area. You can cancel these roots. It will be 120 times 2 over 5. If we divide, it will be 24. 2 times 24 is equal to 48. So the answer of this problem equals 48. There are other ideas for finding areas. If you had any question, if you want to know them, feel free to send message to my WhatsApp number in the description and comments. SMO Junior Section 2019 first round problem number 14. What's the value of square root of 199 squared plus 800? For solving this problem, one way is to calculate this and plus 800, then consider square root. In previous problems, I showed you how to find square root of any number, also with decimal numbers. If you want to learn how to find square root of any number, as I said before, feel free to send message to my WhatsApp number in the description and comments. Here I can say, okay, 199 is 12. Let me consider inside is A. So A is 200 minus 1 squared plus 800. It will be what? It will be 200 squared plus 1 minus 2 times 200, and 800 is what? 8 times 100, or you can say 4 times 200. So you can say, okay, it will be plus 2 times 200. So we can say, okay, it is 200 plus 1 squared. So it is 201 squared. So we want to find a square root of A. So the answer equals 201. SMO 2019 Junior Section First Round Problem number 15. A student wrote the following 99 numbers on the board: 1, negative 2, 3, negative 4, 5, negative 6, negative 2, negative 98, 99. She arbitrarily picked two of these numbers, say A and B, and replaced them by the sum A plus B. For example, if she had picked 37 and negative 24, she would erase those two numbers and add the number 13 to the board. Why? Because 31 plus negative 24 is 13. So you erase A and B and write A plus B instead of them. Suppose that she repeated the process, and after 98 replacements. Why 98? Because we have 99 numbers. In each step we remove one. Because we remove 2, we add 1. So if we consider exactly one number will be the number of the here numbers will be decreased by 1. So after 98 steps we will reach one number. There was one number left on the board. What is the largest possible value of this number? So look, for example, if we consider 1, negative 2, I want to say the last number is not important to select which number first, because you say 98 plus 99. For example, I select negative 4, negative 6. Okay, negative 4 plus negative 6. Then I consider, for example, 3 and negative 98. Then I consider these two numbers. So I have, at the end, I have sum of all the numbers. If you consider the last step, so each number comes exactly once, and it will be 1, negative 2 plus 3, negative 4, 2 plus 97 minus 98 plus 99. So if we consider each of them negative 1, negative 1, negative 1, it will be negative 49 plus 99, which equals 50. So it is not always we reach 50. So also the largest possible value of this number is 50. The answer is equal to SMO 2019 Junior Section First Round Problem number 16. If the equation x minus 1 over x minus 5 equals m over 10 minus 2x has no solutions in x, what is the value of absolute value of m? Okay, so it is x minus 1 over x minus 5. You can factor 2 from this denominator. It will be 2 times 5 minus x. So we know that x is not 5, because the denominator in x5 will be 0. Now, because x is not 5, we can multiply and divide. We can cancel these two things, and we have negative here because it's 5 minus x. So if we cross multiply, we have 2x minus 1 equals negative m. So So we can say what? We can say, okay, 2x equals negative m plus 2. So x equals what? 1 minus m over 2. We know that x cannot be 5. If we want that it has no solution, if it is 5, then we can say it has no solution. It means what? 1 minus m over 2 equals 5. If we multiply by 2, 2 minus m equals 10. So m equals 2 minus 10, negative 8. So m should be negative 8. But the problem says what? Find absolute value of m. So absolute value of m is equal to 8. So the answer equals 8. SMO 2019 junior section first round problem number 17. If s equals this fraction, what's the value of 1011 times s? So each of them, both numerator and denominator, are arithmetic sequence. So the formula of arithmetic sequence is first one plus last one. It is by Gauss idea. First one plus last one times the number of them, which will be 20 over 2 all over 2. So it will be over 2. This one again, first one plus last one over 2 times okay, first one over last one over 2 times the number of them. It's 20 over 2. So we can cancel 20 over 2 from both numerator and denominator. Okay, so here also we can divide, we can cancel these two. So it will be 20 over 2022. If we divide both numerator and denominator by 10, it will be 1011. So 1011 times s equals 1010. So the answer is equal to 1010. If you had any question about this problem or other problems, as I said, feel free to send message to my WhatsApp number in the description and comments. SMO 2019 junior section first round problem number 18. A 5-digit positive integer x has the following properties. First condition, x has distinct digits which are from 1 to 3, 4, 5. And second condition is x greater than 23, 4, 5, 6. 2, 3, 4, 5, 6. How many possible values can x take? For solving this problem, we say, okay, x has distinct digit from this 1, 2, 3, 4, 5 because x is greater than this, so it should be 5. It should have 5 digits, so you can say 5 digits. Let's write 1, 2, 3, 4, 5. If this number is greater than 2, then we are definitely this number is greater than this number, 3, 4, 5. So you say, okay, it has 3 cases times 4 numbers are left, 4 factorial plus. The second case is that the first digit is exactly 2. We know it is not less than 2 because if it is 1, it is not greater than this. So if it is 2, now consider, so here this number is greater than this because of this digit. The next one is greater than this because of second digit from left. So it's 2, it must be 4 or 5. So it will be 2 times 3 numbers are left, 3 factorial. Now suppose it is 2, 3. Now because of this digit it is greater than this. So it must be it's 1, 2, 3, 4, 5. We have only 1, 2, 3, 4, 5. So it can be 4 we have here, so 5. So it will be, how many digits are left? 1 and 2. So you say, okay, plus 2 factorial. And if this is 2, the first one is 2, the second one 3, it is 4. If because of this number is impossible. But 2, 3, 4, the rest of that is 5, 1 or 1, 5. Both of them is less than this. So we should calculate these numbers. 4 factorial is 24. 3 times that is 72. It's 6. 2 times 6, 12. It is 2. 72 plus 12 is 84. 84 plus 2, 86. So the answer is equal to 86. SMO 2019 junior section first round problem number 19. In the figure below, each distinct letter represents a unique digit such that the arithmetic holds. What digit does the letter L represent? We have many problems of these types in SMO problems. This is a little harder than the previous ones, but we will solve this. Look, I times AP, if we consider a 2-digit number, you can say I times AP. We write this as it is a 2-digit number. it is IP, but maybe we have carriers, so you say it's mod 100. Mod 100 equals number IP. And also H times AP, the number AP, this IP here. Again, mod 100 is this. Then you say, okay. We conclude, because IP equals IP, we conclude I times AP is congruent to H times AP. For this problem, you should know the rules in congruency. If you had any problem, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Now, we divide both sides by AP, but we should change this mod by what? I is congruent to H mod 100 over GCD of 100 and AP. Okay, so because the problem says distinct letters, so we know I is not H. So for example, if GCD of them is 1, then they are congruent mod 100, and because they are digit, they are equal. So we know that 100 over GCD of 100 and AP should be at most 9. So what can we conclude? Or you can say this is strictly less than 10. So we can say GCD of 100 and AP should be what? At greater than 10. So because 100, if we consider the divisors of 100, after 10 it will be 20. Let's write all divisors of 100. We know 100 is what? 2 squared, 5 squared. The number of divisors will be positive divisors will be 9. 3 times 3. If you don't know any of them, had any question, feel free to send message to my WhatsApp number in the description and comments. So it is 2, it is 4, it is 5, it is 10. And then I say, okay, 250, 425, 550, 520. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So because it is greater than that, so it is 20. It can be 20 or 25 or 50 or 100. So I can say, if it is 20 or 100, I can say 20 divides AP, or in these two cases, 25 divides AP. So if I want to consider the cases of AP, AP can be what? Can be, for this case, 20, 40, 60, 80, or for this one, 25, 50, 75. It has these cases. Okay, now we've reached this for AP. Let's consider again the main thing here. Let me copy this. Okay, so if I check this product again, I say what? I say PIP is, if I product IP is congruent to P, because it is P mod 10. So you can say what? P times I minus 1 is congruent to 0 if you take P to left hand side. And when it is mod 10 is 0, so one of them we don't have, one of them is 1, or for example I is 1. One of them should be 0 or 5 because it's mod 10. Now here we want to find M. If we multiply H by M, then H is not 0, because if it is 0, 0, 0, 0, then they will be same and they are different. H is a positive number. So when you multiply by M, and here is H, maybe H times A has carrier plus something, but when you see that H times M, it is H. So it is at least, it must be at least H. When it is exactly H, you understand that it should be 1. So M is 1. Now here that we want to consider, we can say I is not 1, so one of them must be multiple of 5. If one of them be multiple of 10, here it is impossible because I should be 1 or P should be 10. They are digits and I is not 1 because M is 1. So case 1 is what? Case 1 is P is 5 and I minus 1 should be even, so I is odd. And case 2 is, this is multiple of 5. I is 6, and it is 5, and P is even. Okay, so in these cases, in many of them, P is 0. If P is 0, then we can say, okay, 0, 0, 0. I here we have, if P is 0, then I plus, and we don't have carrier here. I plus 0 should be A, so I is A. But we know there must be difference, so you can cancel all these cases, 0. So we should only check 25 and 75. So in these cases, let's check. P is 5, so I is odd, or because in this case P is not even, P is 5, so we have this case, so I is odd, and this case will be bad. I is even, P is 5, 25, 75. So let's write them. AP, if you check, it is AP. AP 25. AP is 25. I is odd. And let's paste the things we've reached here. We only said M is 1. M is 1. A is what? A is 2. P is 5. And this P is also 5. This P is also 5. I is odd. This P is 5. And okay, and I is odd. Now, if we check for I can be, if I is 0, then it is impossible because 0, 5, 0. And we said I is odd. If I is 1, it will be 1 to 5. Here will be 1 to 5, and contradiction because S is not 1. If here we have 3, 3 times 1 to 5 will be 3, 7, 5. And we can say, okay, 3, 7, 5, and then I will be 7, not 3. So contradiction. If I is 5, 5 times this will be 6 to 5. It is 5. It is 2. Contradiction. If I is 7, 7 times, let's check 7 and 9. 7, 1 to 5. 9 times 1 to 5. It will be 7 times 5, 35. We have 3. 7 times 2, 14. Plus 3, 17. We have 1. 7 times 1 plus 1, 8. It's okay because it's 7. It's 8, 7, 5. Let's check 9. 9 times 5, 45. 4, 9 times 2, 18. Plus 4, 22. We have 2, 9 times 5. Okay. It has 4 digits, but we have 3 digits. So it is bad. So it should be 7. And it will be 7. It will be 8. So we have this so far. Now I is 7 here. And okay, 5 plus 7. Let's check. 5 plus 7 will be 12. We have 2 here and 1. 1 plus 8, 9. 9 plus 7, 16. We have 16. 1 here. And 1 plus h is c. So now we should find h to see does it have any contradiction or not. H, we want 7, 5. H times 25 mod 100 will be 75. So H must be odd because it is 5. So 1 times 25, 25. It's not 75. 3 is okay. What about 5? 5 is not okay. 7. 7 is okay also for H, but 7 used for I. 9. No, 9 is not okay. So the only possible case for H is 3, so it will be 3. That's okay. 3 times this 3 to 5. 1 plus 3, 4. And we see all the digits are different, so L equals 6. We found L equals 6, but maybe, for example, we check instead of 25, we check at first 75. I want to show you how to reject 75, or maybe it is, for example, in the problem, you should write complete answer. In that case, you should reject 75. And also maybe the problem says how many answers do we have for L? Maybe 75 also conclude another answer. So let's check it again. M, we proved M is 1, A is 75. So it is 7, it is 5, it is 5, it is 5, A is 7. So let's check. In this case, again, we know I is odd because P is 5, we proved before. So if you place 1 here, then you have 175. It is not 1, I should be 1. 2 times the I is even. 3 times 1, this, it will be 3 times 5, 15. 1, 3 times 7, 21, 22. You have to, again, 3, it is not 3. If you check 5, 175 will be 5, 5, 25, 2, 5 times 7, 35, plus 2, 75. We have 3, it will be 8. So here it is 5, it is 7. It's contradiction. 7 times 175 will be what? 7 times 5, 35. You need to only multiply by these two digits because we want to check I. 35, 7 times 7, 49. 49 plus 3, 2. So it's 7. But if you multiply, you have 2 here. And contradiction, all of them so far. 9 times 1, 75. 9 times 5, 45. We have 4, 9 times 7, 63. Plus this will be 67. So again, it is 9, but it is what? It is 7. So that's contradiction. So we will see all of them reach contradiction. So L equals 6. If you had any question about the solution of this problem, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Also subscribe my YouTube channel to have next videos. SMO 2019 Junior Section First Round Problem number 20. If x is a non-negative real number, find the minimum value of this term. Okay, because we want to find minimum value, we differentiate from this. X is non-negative, so also we should pay attention the x that we find. We should differentiate, and also we should, let me tell you, we should consider endpoints. For this one, we don't have endpoints because x can be any number here. For this one, you can say it is x minus 12 squared plus 144. 144 to this, it will be 69. It will be 9. So all x is satisfied. So we don't have endpoints. We need to differentiate. Let me consider this one f. So f prime will be what? Will be 2x over 2 times x squared plus 4 plus 2x minus 24 all over x squared minus 24x plus 153. Now we consider it is equal to 0. So then we can say we can divide these two by these two. Also here we have 2 because it is what? It is something to the power of 1 over 2. So we should consider 2 here. It will be 12. Now we can say, okay, x equals x squared plus 4 equals 12 minus x over x squared minus 24x plus 153. Now we raise both sides to the power of 2. At the end, we should check that the sign of them should be same, x and 12 minus x. So let's raise both sides to the power of 2. It will be x squared plus 4, 12 minus x squared. You can write 12 minus x squared. And if you raise the power of 2 as we've written here, it will be, you can write x minus 12 or 12 minus x squared plus 9. Now let's see what we have. Then if we cross multiply x squared, 12 minus x squared plus 9x squared equals 12 minus x squared times x squared plus 4. So because 12 minus x squared, you can cancel by this. Then you have what? 9x squared equals 4 times this. So 4 times 12 minus x squared. You can consider square root. So 3x, absolute value of 3x. The problem says what? The problem says x is non-negative near real number. So you can say 3x here and 4 times 12 minus x. Because x is non-negative real number. So at first we should check f of 0. It is f of x. For f of 0, we have what? We have 2 plus 153. We should check at the end with this number. So here, without loss of generality, you can say x is positive. So because x is positive, 12 minus x must be also positive. So x is less than 12 because of this if you take negative x to right side. So x is less than 12, so we can say 12 minus x is positive. So absolute value of this will be 2 times 12 minus x. Now we say, okay, negative 2x, if we take it to left hand side, will be 5x 24. So x will be what? Will be 24 over 5. And okay, yes, exactly. And it satisfies all these things. Okay. Now let's replace this here. Copy to clipboard. Let's paste it here. It will be what? The first one is what? This one is x squared over 4. 24 squared is 576 over 25 plus 4. Square root of this. And it was what? It was 12 minus x squared plus 9. So a square root of 12 minus x. We can say what? We can say, okay, 12 minus x is 24 over 5. It's 60. 60 minus 24 is 36. 36 over 5. So it will be 36 over 5 squared plus 9. Now we want to simplify. It will be what? 4 times 25 will be 100. 100 plus 576 will be 676. It will be 26 because it is 26 squared over square root of 25 will be 5. And for this one, you say, okay, 5 square root of 36 squared. 36 squared is 1296. If we calculate, plus 9 times 25. 9 times 25 will be 45. 225. So if we add up these two numbers, 5 plus 6, 1, we have 5 plus 6, 11, we have 1, 2 plus 9, 11 plus 1, 12, we have 1, 2 plus 2, 4, 4 plus 1, 5, it will be 15, 21. Now if you want to consider square root, it's multiple of 9, we can write 9, 1, 6, 62, 8, no, 62, 6. 81, then it is 9. It is 9 times 13 squared. So it is 3 squared times 13 squared. We can say, okay, it's 26 over 5 plus 39, 3 times 13 over 5. If you add up these two numbers, 9 plus 6, 15, we have 1, 3 plus 2, 5, 5 plus 1, 6 over 5 is 13. You can also check x near this number that we've replaced 24 over 5, this x that we found. 24 over 5, you can see the answer is minimum. So let's see, the answer is equal to 13 minimum. Also, if you check with this case, endpoint, because the problem says x is non-negative. So here, so we have endpoints because of this condition. So 2 plus this number. This number is greater than 144. It is greater than 12. So the whole part is greater than 14. But here the answer is 13. So the answer is equal to 13. SMO 2019 Junior Section First Round Problem number 21. A positive integer is said to be 12-ish if the sum of digits in its decimal representation is equal to 12. For example, the first four 12-ish integers are 39, 48, 57, and 66. Because some of the digits look 4 plus 8, 12, 5 plus 7, 12, 6 plus 6, 12. What is the total number of 12-ish integers between 1 and 999? Okay, so if we consider first one is 39 because we need 2 digits at least, and if you place 2 here, 29 is 11 sum of digits. So the first number is 39, and let's consider the first 2-digit numbers. 48, 57, it will be decreased by 1, 66 ones digit, 75, 84, 93, finished. 2-digit numbers. Now we consider the 3-digit numbers, that hundreds is 1. So you say 1. Now sum of the other 2 digits should be 11. So 29, it will be okay. 38, So you go until 1, 9. Some of them should be 11, 1, 9, 2. Here you have how many numbers? 9 minus 2, 7. Here you have how many numbers? 9 minus 1, 8. The next one. 2, you say, okay, 2, 1, and 9. It's okay. 2, 2, 8. You go to 2, 9, 1. So how many numbers do we have here? 9. The next one. 3, 0, 9. 3, 1, 8. 2, 3, 9, 0. How many numbers do we have here? It's 10. Now the next one. 4, if you want to reach 0, it should be 8, then 4, 1, 7. You go until 4, 8, 0. For 9, you can't have 9. Because 4 plus 9 will be 13 and greater than 2. So here, 8, 9. 9 cases we have. Now here, look, 7, 8, 9. It is increasing to 10, then it will be decreased, 9. The next one will be what? 5, 0, 7. 2, similarly, 5, 7, 0. It will be 8. The next one will be 6. Considering these cases, after some steps, you can write them quickly to 6, 6, 0. It will be 7. You can go to 7, 0, 5, 7, 5, 0. It will be 6, 8, 0, 5 to 8. Sorry, 8, 0, 4 to 8, 4, 0. It will be what? It will be 5, 9, 0, 3. Last one. 9, 1, 2, 9, 2, 1, 9, 3, 0. So the answer here will be 4. So finished. Now we should add these numbers. 7, 8, 9, 10. Also, after writing, for example, 9, 8, you could ignore them. Consider only 9, 4. You say, okay, 10, 9 to 4. Plus 10 plus 9 to 8, 7, 6, 5, 4. So here, if we want to calculate, we can say, okay, consider this part and this part. There are arithmetic sequence. First one plus the last one, 17, times the number of them, 4 over 2, plus this one. First one plus the last one, 9 plus 4, 13, times 1, 2, 3, 4, 5, over 2. It will be 3. Here it will be 2. It will be 2 times 17, 34, plus 39, 9 plus 4, 13. We have 1, 3, 3, 6, plus 1, 73. So the answer is equal to 73. SMO 2019 Junior Section First Round Problem number 22. Two Secondary 1 and M Secondary 2 students took part in a round-robin chess tournament. In other words, each student played with every other student exactly once. For each match, the winner receives 3 points and the loser 0 points. If a match ends in a draw, both contestants receive 1 point each. If the total number of points received by all students was 130 and the number of matches that ended in a draw was less than half of the total number of matches played, what's the value of M? Okay, so we have M secondary 2 and 2 secondary 1, so we have M plus 2 students, all of them play together. So you say this, something like this, all of them are connected, 1, 2 to M plus 2. If we connect all of them, we have M plus 2, choose 2 pairs, so we have this number of games. And some of them are, it has winner, you call this, for example, W, the number of plays that it has winner. And okay, so we can say the number of games that ended in a draw will be 2 M plus 2, choose 2 minus W times. So in that game, we have 1 for each student. So we have 2. And in the game that we have winner, we have 3 scores in total. So 3W equals 130. So 2 times the number of games that ended in draw plus 3 times the number of games that we have winner. So if we simplify, it will be M plus 2, or I can say M plus 2 times M plus 1 plus W equals 130. And the other condition is what is the number of games that ended in a draw was less than half of the total game. Ended in draw will be m plus 1, choose 2 minus W will be less than what? Less than half of the game. So here we can conclude what? We can conclude m plus 2, if we multiply by 2, m plus 2, choose 2, 2 minus 1 will be less than 2W. Now here, if we know W is at least 0, so we can say, let me write the rest of that with black, we know it is greater than m plus 2 times m plus 1, so if m is 10, it will be if m is greater than equal 10, then we have 12 times 11 will be 132, and that's contradiction. So m is at least 9. M is at most 9. Also, we can say the number of games 130 is at most, if all of them have winner, it will be 3 times m plus, because if it ended in draw, the total score will be 1 plus 1, 2. So it is maximum 3 times m plus 2, choose 2. So here we can say, okay, if m, for example, is 7, if m is 7, it will be what? 3 times 2, choose 9. 2 choose 9 will be 9 times 8 over 2, 9 times 4. It will be 36, and it will be 108, and that's contradiction. If m is 8, 3 times 10 choose 2, it will be 3 times 45, and it will be 135. So we've proved that m is at least 8, and at most here we've proved it is 9. So m is 8 or m is 9. So let's check both cases. If m is 8, so we have what? We have m plus 2, choose 2 minus W, the number of games ended in draw, times 2 plus 3. W equals what? Equals 130. Now 10 choose 2 is 45. 45 times 2, 90. 90 minus 2W plus 3W plus W is 130. So W will be what? Will be 40. Let's check. Yes, 40. And the number of games that ended in draw will be what? Will be 5, because all games will be 45, and the problem says 5 is half of 45. It's okay. So let's check for m9. The answer, now we understand that m equals 8. The answer is 8 because we have one answer. The problem says m is what? But let's also complete this problem. If m is 9, then let's replace here. 11 choose 2 will be 11 times 10 over 2 will be 55. 55 times 2 will be 110. Plus 3W minus 2W will be plus W, 130. So W will be what? 20. Now the number of games that ended in draw, we can say it's 11 choose 2 minus what? Minus the number of games that has winner. It will 55 minus 20 will be 35. But 35, the whole number of games is 55, and 55 over 2 is 27.5. 35 is not less than that. So here it's contradiction. So the answer is equal to m, that equals 8. SMO 2019 Junior Section First Round Problem number 23. ABCD is a square sheet of paper with side of length 6. The paper is, so it is 6. The paper is folded along a crease line EF here, so that points A and B now lie on A prime. This A go to A prime and B to B prime. So we can say, okay, if I consider this length is A, so it is also A. If I consider this length is B, it is also B, because FB equals FB prime, EA prime equals EA, as indicated in the diagram. If H is the intersection of A prime, B prime here, and CB, what's the perimeter of triangle A prime CH. Okay, so I consider, for example, this angle is alpha because it is 90. It is 90 because this angle is this angle. It is 90 minus alpha plus 90. It must be alpha. It is 90. It will be 90 minus alpha. 90 minus alpha. It is 90 because it's equal to this angle. So this angle is alpha. So we can say what? We can say these triangles are DA prime are similar. DA prime E is similar to A prime CH is similar to triangle FHB prime. Now the problem wants what? A prime CH perimeter of this. So suppose that, for example, we say perimeter of this is P. So because this triangle and this triangle is similar, if the ratio this over this is K1, you can say the perimeter of this is PK1. The perimeter of this also, if it is K2 times this, it will be PK2. Now, if we add all these perimeters, P plus PK1 plus PK2, we see that it will be perimeter of the square. Why? Because it is this side, this one. This one will be the hypotenuse of this triangle. This one will be here, and the whole this part will be AB. This one will be this. So it will be 4 times 6. The perimeter of square 24. So P times 1 plus K1 plus K2 equals 24. So P equals 24 over 1 plus K1 plus K2. We want to find P perimeter of triangle A prime CH. So we should find K1 plus K2 is what? This over this and plus this over this. Okay, now here I want to say that CH plus HF plus HB prime is 6. And we want to calculate. So at first I say, okay, it is A. We know the whole term is 6, so it is 6 minus A. This part, it is B. I want to find HF. I say, okay, cos alpha is what? Is B over HF. Also, you can say cos alpha here is what? Is 6 minus A over A in this triangle. So we can say HF, if we cross multiply, will be AB over 6 minus A. So we found HF. Now we want to find B prime F also. We know is what? We know is B, so we should find CH. Now, this length, if you use Pythagoras theorem, dA prime squared will be what here? Will be A squared minus 6 minus A squared, which will be 12A minus 36. So d prime A, this length will be 12A square root of 12A minus 36. Now, because the whole DC is 6, so this length will be 6 minus 12A minus 36. Now, here I want to find what? I want to find CH prime. So I can say tangent alpha, if we want to find tangent alpha, if you use tangent alpha in this triangle, it will be what? It will be root 12A minus 36 opposite over adjacent over 6 minus A. If we use in this triangle, it will be CH over what? 6 minus 12A minus 36. So we can conclude that CH is what? CH is, if we cross multiply, 6 times root 12A minus 36 minus this times this will be minus 12A minus 36 all over 6 minus A. So CH is this, we found all these things. So CH, that is this, let me copy, Control C. CH is this plus HF, we found HF is AB over 6 minus A. AB over 6 minus A is HF. And F prime, FB prime is B. Sum of all of them will be 6. Okay, now we multiply both sides by 6 minus A. So let's see what we have. 6 times square root 12a minus 36 minus 12a plus 36 plus ab plus b times 6 minus a, which will be 6b minus ab, equals 6 times 6 minus a will be 36 minus 6a. We can cancel 36 from both sides. Then let's see what we have. We can cancel AB and negative AB. So now we can say, okay, we can divide both sides by 6. It will be 12a minus 36 minus 2a plus b equals negative a. So you can say 12a minus 36 equals 2a minus a, and b, take b to the right hand side, negative b. Okay, so we found this equality. Now our goal was what? Our goal was, let me copy this part. Let me copy grader. Okay, we wanted to find k1 plus k2. We found this relationship here. Okay, now for example, if I want to find k1, I can say I know this. It is 90 minus alpha, 90 minus alpha. So it is 6 minus a. Let me write rest of that with green. It will be 6 minus a over 6 minus root 12a minus 36. Plus, here, if I want to write 90 minus alpha, it will be b over 6 minus 12a minus 36. It is k1, it is k2. And it will be what? It will be 6 minus a plus b. So 6 minus this, 6 minus 12a minus root 12a minus 36. We found that if I call this one star by star, you can say, okay, you can replace 6 minus a minus b. And you can see, okay, it is 6 minus a plus b, it is a 1. So k1 plus k2 equals 1. Now we can solve the problem. Why? Because k1 plus k2 is 1. It will be 24 over 1 plus k1, k2, 1 over 2 equals 12. So the answer is equal to 12. SMO 2019 junior section first round problem number 24. In the following diagram, BED is 30 and DBE is 15. Okay, so we can say it's exterior angle 15 plus 30, 45. And 135 here. This angle will be what? X 45. 180 minus this will be 135 minus x. And it says if CD equals DE, what's the value of x? This in degree. Now here we want to use ratio lemma. If you don't know that, you should use 2 sine rule to prove that. Ratio lemma, let me explain. There are around 50 important ideas in geometry. Also in other topics, you have some important ideas. You should learn them, and they are very useful from qualifying level up to IMO. If you have this, ratio lemma is this. And the proof is so much easy. You should use 2 sine rule in these 2 triangles. Sine A1 over sine A2 equals BP over PC times this one B over C. Or instead of B over C, you can write sine B over sine C. So if I use ratio lemma, if you want to use it in exam, it is not so much famous, so it's better to prove it if it is in round 2 or national level. Now, here, we say, okay, sine 135 minus x, here we want to use ratio lemma. Sine 135 minus x over sine 15, it will be CD over D, which equals 1 times sine x over sine 30. These are equal, it will be sine 30, it will be 1 over 2, it will be 2 sine x. Now we can cross multiply. Also, you can write instead of 135 minus x, you can write 45 plus x, because some of them is 180 and so sine of them are equal. Equals 2 sine x sine 15. Now we can change product of signs to addition. You can say, okay, it's cos their difference x minus 15 minus cos sum of them x plus 15. Now here we take negative cos x plus 15 to left hand side, so we have what? Sine 45 plus x, and also instead of sine 45 plus x, I write cos 90 minus x, which is 45 minus x, and negative will be positive plus cos x plus 15. We know it is equal to cos x minus 15. Now we change cos sum of cos to product. It will be 2 cos sum of them 30, because we add, we say 2 cos sum of them over 2. Sum of them will be 60. 60 over 2 is 30, and times cos their difference will be this minus this will be 30 minus 2x over 2 will be 15 minus x, which equals cos x minus 15. Now you can factor from cos 15. We know they are equal. 15 minus x, because you can negate 15 minus x, or we can write both of them as x minus 15. Let's write both of them as x minus 15. So you say, okay, x minus 15, it is equal to this. It will be 2 cos 30. Cos 30 is root 3 over 2. 2 times that will be root 3. And it is cos x minus 15 minus 1. It is equal to 0. We know it is not 0, so we conclude what? Cos x minus 15 equals 0. Now, if you imagine the unit circle, we know x is what? X is an angle of the triangle. So it is from 0 to 180. Also, because we have 45, you can say it is less than 135. So it will be from 0 to 135, this part. So x minus 15 will be what? Will be some part from this part to this. The only point here that cos of that is 0 is exactly this point. So x minus 15 equals 90 degree. So x equals 105 degree. So the answer is equal to 105 degree. SMO 2019 Junior Section, first round, problem number 25. In the following diagram, P1, P2 to P8 are points on triangle ABC such that AP1 equals AP8 equals PI plus 1. So for I 1 to 7. So P1, P2 to 3, 4, 5, 6, 7. A to P7, P8. What's the value in degree of BAC? So let's consider this angle is alpha. So let me minimize. Because AP1 equals P1, P2, it is also alpha. AP8 equals P8, P7, it is also alpha. Now we say, okay, it is exterior angle of these two triangles, so it is sum of this plus this. So we can say what? It is 2 alpha. Similarly, it is exterior angle, this alpha, alpha. Sum of two non-adjacent angles, 2 alpha. Now it is 2 alpha, it is isosceles triangle, it will be 2 alpha because P1, P2 equals P2, P3. Similarly, it is 2 alpha, it is 2 alpha because it is isosceles triangle. And then we say, okay, it is 2 alpha exterior angle, it is 4 alpha, it is 2 alpha exterior angle, 4 alpha. Then you say, okay, it is isosceles triangle, it is 4 alpha, it is isosceles triangle, it is 4 alpha. Oh, sorry, here from 4 alpha, let me correct it. Until 2 alpha, it's okay. It's 2 alpha. But here, this plus this is sum of this plus this. Because exterior angle here, we can say is similar to this. Why? Because this plus this plus this is 100 degree, this plus this is 180. So you can say because it's 4 alpha, it is alpha, it will be 3 alpha. Similarly here, you can say we have alpha here, 2 alpha. It will be 3 alpha, so it is isosceles triangle P6, P7, P5. So it will be 3 alpha. P2, P3, P4 is isosceles, so 3 alpha until here. Okay, so this angle is this angle. is exterior angle, we can say this plus 2 alpha is 3 alpha, 3 alpha. Look, or like this. This plus this equals this plus this. Why? Because sum of these two plus this angle is 180, sum of these two plus this is 180. So for example, if it is x, it is y, z, t, so x plus y equals z plus t. We use this, we can say idea or lemma several times. Here it's 2 alpha, 3 alpha, 3 alpha, 6 alpha. 2 alpha, so it will be 4 alpha because it is isosceles triangle P4, P3, P5. 4 alpha, it is 4 alpha, 3 alpha we have, so it is alpha. And similarly, you can say again, it is 2 alpha, 3 alpha, 3 alpha, so 6 alpha, 2 alpha, so it will be 4 alpha. Because P5, P6, P4 is isosceles, so it is alpha. Now we say, what if we consider triangle AP4, P5? Alpha plus 3 alpha plus alpha plus 4 alpha plus 3 alpha plus alpha plus 4 alpha equals 180 degrees. So 4 plus 4 plus 1 will be 9. 9 alpha is 180 degrees, so we can conclude alpha equals 20 degrees. So the answer is equal to 20.